Welcome everybody to Algebra 2, Section 2.3, Multi-Step Equations. So steps to solve a multi-step equation. Step 1 is to distribute. I'll put if necessary. Step 2 is to combine like terms. That would be ones on the same side of the equal sign. And step 3 is solve, but I want to clarify that because all of these steps are to solve. That's by going back to the same two-step equation solving, aka solve using SADMAP typically. So on number 1 here, there's no parentheses, so we don't have to distribute, so we'll just jump to step 2 here. Step 2, we combine these like terms on the same side of the equal sign, so we're only focusing on this side currently. And if there were like terms over here, we combine those as well on that right side separately from the left side. On the left side, we notice 9x and negative 7x there, keeping that minus with the 7x as a negative, and we get 2x. 1 and negative 5 combined to be negative 4, and that equals negative 20. Now we add 4 to both sides, just like we would before, and get 2x equals negative 16. Dividing both sides by 2 gives us x equals negative 8. So once we got down to this orange part here, after we combined like terms, we had our two-step equation like we did last section. But before that, we had to combine like terms, which is one of the new steps today. Now, if we were to plug this back in to check your answer, that x is in fact negative 8, how you would do that? Well, you'd plug it into both or any spot you see the variable. So any spot that you see the variable, you plug it in. Note I'm using parentheses here on purpose. We're asking, does this equal? And so over here I get negative 72 plus 1 plus 56, because a negative 7 times a negative 8 minus 5, and asking, does that equal negative 20? And as I combine like terms here, all of these will add up to, you guessed it, negative 20, and it does check out. Number 2 here. We have no parentheses to distribute, so we just focus on combining like terms on one side of the equal sign. And if once again there were like terms over here, if this was like x plus 4, we combine those to get us 12 on that side. But it's not that way, so we're just going to leave the right side of the equal sign the exact same and do nothing over there. On the left side, we can combine the d's, the variables. 5 minus 3 is 2, so we keep the variable, call it 2d, plus 7. We haven't done anything with plus 7, so we just rewrite it. Now this is a two-step equation, which we solve by subtracting first. So we subtract 7 from both sides to undo the addition of 7, and we get 2d equals 1. Now we divide by 2 to undo the multiplication of 2, and get d equals 1/2, or 0.5. Number 3 here. Ooh, some fractions. How exciting, okay? So once again, nothing to distribute here, but we do have to combine these. Now, if we want to combine those, we have to get common denominators. They currently have a denominator 4 and 2, not the same. So our common denominator is going to be a number that 4 and 2 could both multiply up to, and the smallest number that you could do that with is 4. If you wanted to make it bigger, you certainly could. You would just have to simplify more at the end. So this fraction is good as is. In this fraction, I need to multiply the denominator by 2, which means I need to multiply the numerator by 2. So I will have 3/4 x plus 1 minus 2 over 4x equals 2. Now if I combine those, I have the 3 minus 2 on top, gives me 1, keep the bottom the same, and I get 1/4 x plus 1 equals 2. If you wanted to do all that work with the fractions off to the side and then put it back in the problem, you're obviously more than welcome to. You're always welcome to put stuff outside and then bring it back in. So now I undo this addition of 1 first by subtracting 1, and I get 1/4 x equals 1. Multiply by the reciprocal to undo the fraction multiplying with x. So 4 over 1, or 4. The 4 is reduced, and I get x. Multiply the other side by 4, or 4 over 1. I don't have to put the denominator here because it's just a 1, and I get 4. Now we're going to involve the distributive property. So here we have, before we can combine these, we have to distribute the 4. So 4 times 2x is 8x. 4 times 1 is 4. Minus 5x is just hanging out, and equals 10 is also just hanging out. Now this becomes like the problems we had on 1, 2, and 3, where we combine our like terms. So 8x minus 5x is 3x, add the 4, and we get 10. Subtract 4 from both sides to undo the addition of 4, and we get 3x equals 6. And last but not least, we'll divide by 3 to undo the multiplication of 3 and get x equals 2. And that would be our final answer. And if you were to plug it back in, you'd have to distribute times whatever you get, or combine in here first. Moving on. We got a bunch of problems here that are all doing the same exact thing. So let's get to it. So we have two different parentheses, so we have to distribute to each of those. So in the first one, we distribute the 3, and we get 3x plus 15. Common mistake can be made here. A lot of us might do negative 2x and then call this a negative 2, but that's wrong. What we have to do instead is call this plus a negative 2, and then we take negative 2 times x, and negative 2 times negative 1, and that gets us a positive 2. And that equals 7. Combining like terms, I'm going to combine my x's and get 1x. Combine my 15 and 2, the constants, and get 17. That equals 7. Now, if I were to take 17 and subtract it from both sides, undo the addition of 17, I get x equals negative 10 as my answer. No need to divide here, because x is already a 1x, or by itself. On number 6 here, we have 91 equals negative 7 times the quantity, or the parentheses of, 3a minus 1. So our first step is to distribute this negative 7, and we get 91 equals negative 21a plus 7. So then we subtract by 7 on both sides to undo the addition, and we get 84 equals negative 21a. Dividing both sides by negative 21, we get negative 4 equals a as our answer. I want to note here, we actually have another way we could do this problem. So let me rewrite the problem here, and I want to note another way we could solve it if you would so choose. So distributing is really the same thing as multiplying. Okay, distributing is multiplication, you're just repeating it. So if we wanted to, we could divide to undo the multiplication. And you would divide by whatever you're distributing by, in this case, negative 7. And negative 7 and negative 7 undo each other and both become 1. And you divide the other side by negative 7 as well. So on the left side, if you do this, you get negative 13. On the right side, you end up just getting 3a minus 1, the part that you didn't divide. Now the reason that division is able to work like we did there is because this negative 7 is multiplying with 3a minus 1. If this was adding here, you certainly could not do that. Okay? It would be very different, and that would not be okay. Or if we had plus 5 over here, we couldn't do that either because we'd have to divide everything by negative 7, and that would create a fraction. So you could divide everything, but my goodness, would that be more complex. So I waited to do it on this problem because this is the only problem where we had nothing on the one side except for what's being distributed and the parentheses. So here we had this 5x over here that complicated things. And here we had two different sets of parentheses that complicated things. But here we just have one set of parentheses and one thing distributing into it. Now if we continued solving this problem, our numbers are obviously different than they were on the left. We would add 1 still to undo the subtraction of 1 and get negative 12 equals 3a. Now we divide by 3 and negative 4 equals a. We get the same exact answer. So this is certainly an option available to you if you would like. Once again, when you can take advantage of it is if you have something distributing to only one parenthesis with nothing else on that side. And then you can take advantage of it because you divide everything by negative 7 and there's only one thing over here that divides well by 7 or negative 7. If it didn't divide well by negative 7, which this one does, and by dividing well I mean not make a fraction, I would not encourage you to try that out. But most of us are probably going to be more comfortable using this method, so feel free to continue using that method. Number 7 here. Our first step is to distribute this 5. However, it's not just a 5, it's a negative 5. So I'm going to rewrite the 4m, and I'm going to distribute the negative 5 to get negative 15m minus 50 equals 126. Combine like terms to get negative 11m minus 50 equals 126. Add 50 to both sides to undo the subtraction of 50, and we get negative 11m equals 76. Then, my apologies, I did my math wrong, that'd be 176. Then we're going to go ahead and divide by negative 11, and I get m to equal negative 16. Number 8 here. we have negative 3 times the quantity of k minus 8 minus k plus 5. So we distribute the negative 3 and get negative 3k. Distribute the negative 3 and get positive 24. This minus sign, we pretend it's either a negative 1 and distribute it, or change it to a positive and change every sign inside. Either way results with the same numbers, minus k plus a negative 5 or minus 5. Combining like terms here, we have negative 3k and negative k that give us negative 4k. 24 and negative 5 give us 19. Then we're going to go ahead and subtract 19 from both sides and get negative 4k is equal to 4. Then if we divide both sides by negative 4, we get k to equal negative. Next up, number 9 here. We have to distribute this negative 6, making sure we do make it a negative 6 as we distribute. So 20 equals 10x, all remains the same. We get negative 12x minus 30. Combine like terms on this right-hand side. We have those x's that give us negative 2x. And then we have the minus 30 still. Add 30 to both sides. And we get 50 equals negative 2x. Divide both sides by negative 2. And we get x equals negative 25. Next up, number 10. Distributing starts with 8 into 2w, giving us 6w. 8 times negative 1 gives us negative 8. Minus 4w equals negative 116. Now we'll go ahead and combine like terms to get 12w minus 8 equals negative 116. Adding 8 to both sides, we get 12w equals negative 108. Now we'll divide both sides by 12 and get w to equal negative 9. On to our last page of notes for this section, number 11. Here we just have to distribute a negative here, so we can add and change the signs inside, or you can think of it as multiplying by a negative 1. You get the same results. I have 11h minus 2h, and that gives me 9h plus 1 equals 118. I subtract 1 from each side, and I get 9h equals 117. Dividing by 9, h equals 13. Next up, number 12 here, we will start by distributing this 1/2. 1/2 times 10x, or 1/2 of 10x, would be 5x, and 1/2 times negative 2, or half of negative 2 is negative 1, plus 3x. I think I wrote too many negatives there. My apologies on that. I didn't like that I erased it there. There we go. Now we'll combine like terms on the right hand side, and those x's combine to be 8x minus 1. Add 1 to both sides, and we end up getting negative 24 equals 8x. Once we go ahead and divide by 8, we get x to equal negative 3. Number 7 here, we distribute negative 5 over 2. I'm going to make sure this is a negative here. 7 minus negative 5 over 2 times 8r. I'll do that off the side here. Put 8r over 1. Reduce 2 and 8, become 1 and 4. Multiply straight across, we get negative 20r. So minus 20r. Negative 5 over 2 times negative 6. So negative 5 over 2 times negative 6 over 1. 2 and 6 reduced to 1 and negative 3. And we end up getting positive 15. Plus 2r equals 32. I'm going to fix this 20 over here. That turned out pretty poorly. Combining like terms here on the left-hand side, 7 and positive 15 combine to be 22. Negative 20r and 2r combine to be negative 18r. Now if I subtract 22 from each side, negative 18r equals 10. Dividing each side by negative 18, 18 does not go into 10, but it does reduce by 2 on the top and the bottom. We get 5 over 9, and it is still negative. Whether the negative is out in the front, on the top, or the bottom, it does not matter. Our last problem here, translate and solve. I encourage you to attempt this one on your own, and then see what I have. 5 times the difference, so I'm going to start with 5 times something. The difference tells us that it's a result of subtraction. So we're going to have subtraction coming in parentheses to figure out what two things are we subtracting. So the first thing we're subtracting is, after the word difference of, twice a number, so 2 times our variable, I'll call it x, you can call it whatever you want, and 3, so 2x minus 3. So 5 times the difference, 5 times the result of the subtraction of 2x, twice a number, and 3. Comma, decreased by, so subtraction, the sum of, so adding, and we have to have the result of that first, and then we decrease it, so that has to be in parentheses, the number, so the same one we used before, x, and 8 added together, and then equals 13. And this would be our setup here. Now we're going to go ahead and distribute this 5 and get 10x minus 15. Make sure that we change this sign and change the signs of the parentheses afterwards, and we get negative x minus 8 equals 13. Combining like terms, our x's combined to be 9x, our constants combined to be negative 23. Adding 23 to both sides, and we get 9x equals 36. Divided by 9 on each side, and x equals 4. On this page, we have solving multi-step equations with fractions. And when you have a problem with lots of fractions like here on 14 and 15, you can actually clear the fractions before you begin, which is getting rid of them. And how you do it is by multiplying every part of the equation by the least common multiple of the denominators. So on 14 here, our denominators are 3, 6, and 9, and the least common multiple is the smallest number that they all can multiply up to. And here, the smallest number 3, 6, and 9 can multiply up to is 18. And so we're going to multiply every single fraction, or each part of this problem, each term, by 18, or 18 over 1. And as we do this, it's important to cross-reduce each fraction. So 18 and 3 reduced by 3 to become 6 and 1. And then we distribute the 6 into that parentheses, into the numerator. And we get 6x plus 6. 18 and 6 in the next fraction reduced by 6 become 3 and 1. And distribute the 3 in to get positive 3x. Have our equal sign. And on the right-hand side, 9 and 18 reduced by 9 become 1 and 2. 2 times 1 is 2. And now we have this nice equation where there's no more fractions currently, and this becomes a lot easier to work with. As we combine like terms, 6x plus 3x is 9x. We have 9x plus 6 equals 2. Subtracting 6, we get 9x equals negative 4. Then we're going to go ahead and divide by negative 4, divide by 9, my apologies, and get x equals negative 4 over 9, which does not reduce. So we still ended with a fraction, but all of our work in the middle we had without fractions, which was quite handy. Now if you wanted to, you could have, instead of doing the part where we multiplied everything by 18 over 1 to clear or get rid of the fractions, you could have instead chosen to get common denominators. Your common denominator would have been 18, and so you'd say you'd multiply the top and bottom of this one by 6, top and bottom by 3, and top and bottom here by 2 to get them all up to 18. And you have to distribute the 6, distribute the 3, distribute the 2. And so we get all these same numbers, except that we'd also have to have the denominator of 18 the whole time. So it becomes a bit messier, in my opinion, to do it that way. So this is an alternative you could do like we did here. On number 15, 3 denominators, 2, 6, and 3. Try and figure out what you believe to be the least common multiple, perhaps pausing the video and then playing it once you have found what you believe to be it. So here the least common multiple that 2, 6, and 3 can multiply up to is actually just 6. While they could all multiply up to 12 and 18 and 24, so on and so forth, the smallest one is 6. So this first fraction we multiply by 6, or 6 over 1, same thing with the second, and same thing with the last one. As we reduce on the first fraction, 6 and 2 reduced by 2 to become 3 and 1, and multiply 3 times 1 to get 3. The second fraction, 6 and 6 reduced by 6 to become 1 and 1. We do 1 times a, which is just a. Drop our equal sign. And in the last fraction, 3 and 6 reduced by 3 to become 1 and 2. And 2 times 1 is 2. Now I subtract 3 from each side, and a is by itself, and it equals -1. So this ended up being no fractions at all. How convenient. And now this is the end of section 2.3.